Hello, everyone. Today we're going to talk about what is called implicit differentiation. All right. To do implicit differentiation, what we're going to do is we're going to differentiate both sides of the equation with respect to x, treating y as a differentiable function of x. Okay? So we differentiate both sides, and then we're going to collect terms with dy dx on one side, or I'm going to probably write it as y prime, either one. And then we're going to solve for y prime. So let's go ahead and do this. So let's look at the example. Let's say we have x squared plus y squared is equal to 25. So typically when we've been taking derivatives, we just have one variable. We've been just taking the derivative of x, and then we use our rules. We find y prime or f prime of x, whatever we want to call it. But I don't have a y here. I have y squared. So what I have to do, since this is not a function, we use implicit differentiation. So I take the derivative of x terms normally, but when I take the derivative of y terms, I have to multiply by y prime. So I'm going to take the derivative of x squared, which is 2x. We do that normally. I'm going to take the derivative of y squared, which is still 2y. But since I'm taking the derivative of something that's not x, we have to multiply by y prime. And then the derivative of 25 is 0. All right. So again, in this step, I'm taking the derivative of each term normally. But if I take the derivative of something that is not x or constant's okay. I know those derivatives, they're normal. But when I take the derivative of y, I have to multiply by y prime, which is an application of the chain rule. Right. So now that we have all of our derivatives, we want to find what y prime is. So what we're going to do is I'm going to move everything to one side that doesn't have y prime, or I'm isolating the term with y prime. So now I have a y prime on one side, and then I have my minus 2x, which doesn't have a y prime. Now I can solve for y prime. I can divide by 2y. So we now have our derivative of minus 2x divided by 2y, which those 2's would cancel out, and I have minus x over y, which would be my derivative. Right. So let's look at another one. So this one was pretty straightforward. The only difference is we took the derivative of y, we multiplied in that y prime and solved. Let's say we have something like this. I have x to the third plus y to the third equals 6xy. So now I have a y on both sides. And I have to think of some of my normal derivative rules that I know. So let's start by taking the derivative of the left side. Left side is what we just did. Derivative of x squared is 3x squared. Derivative of y to the third is 3y squared, but then times y prime. But then this 6xy is a little trick here. The derivative of 6xy, we'll make a little side note. I have to use the product rule. So I have to take 6x as one of my functions, and I want to pick y to be one of my functions. Okay. So I have 6x and y. The derivative of 6x is 6. The derivative of y isn't just 1 here, it would be y prime. The derivative of y would be 1, but then every time we take the derivative of y, we're multiplying by y prime. So we do our product rule. I'd have 6x y prime plus 6y. So 6x times y prime, 6 times y. So I have 6x y prime plus 6y. And now this is where I want to isolate the y prime. It doesn't matter which way you move it, as long as y primes are on one side, and on the other side is everything without y prime. So let's move over the 3x squared term. So I have 3y squared, y prime on the left side, 6xy prime plus 6y minus 3x squared. And then I can move over the minus 6xy prime. So now I have 3y squared y prime minus 6xy prime, which is equal to 6y minus 3x squared. So let me just go over again what I did here. So I wanted the prime terms on one side and then the terms without prime on the other side. So in step 1, I moved over the 3x squared. So then I had just one y prime term left on the left side, and then I moved over from the right side to the left side the other y prime term. So I have y prime terms on one side, and then terms without y prime on the other side. And the reason we have to do this, in the first one it didn't really matter, because we only had one y prime term. But now when we have multiple y prime terms, I can now factor that out. I can factor out a y prime. When I factor out a y prime, I'm left with 3y squared minus 6x, and the rest stays the same. Now that that y prime is factored out, I can divide by whatever's left. So we have y prime is equal to 6y minus 3x squared over 3y squared minus 6x. Okay. So when you try these, you can get multiple different answers that are completely equivalent here. It always depends on which way you move the variables. If you move the terms the other direction, like let's say you put the y prime terms on the right side and then put the non-y prime terms on the left side, everything's going to be different by a negative sign. So all the terms should be the same, but all the negatives will be flipped. So they're equivalent answers, but it might not look exactly the same if you solve the problem just in the other direction. It doesn't matter which way you solve it, but you could get a different answer that is still correct here. That's going to be it for today. I hope everyone has a great day.